Hello. Is the audio good? Great. All right, so hello. I'll try very hard not to fall asleep during my own presentation, but no guarantees. So this talk is called Anyone Can Edit, and so it's this simple, ridiculous idea. What if anyone could edit anything? So what stops us from attaining that utopian vision of the future? Well, access to technology, copyright, DRM, tech literacy, free time, resources. These are all annoying problems that are getting in the way of our hacker dream of being able to modify everything we see in our environment to our own fulfillment. So there's this kind of, I mean, it's a good attempt, I think, but there's this phrase, you own your data, that has come about lately, but I think it doesn't really go far enough. But I'll get a little more into that later. The problem is the own part. I don't really like that part as much. So wikis are pretty cool. I quite like wikis because it's just a website. Anyone can go to it pretty much who has a computer, and also usually anyone can edit that wiki. So often without even making an account, and this works pretty well most of the time. You just click edit, everyone can participate. It's a lot like NPM. There's very low friction to making content, to storing that content, and collecting that content so that everyone basically has it. It doesn't really belong to any particular person. I think wikis are also a really interesting data model for applications. So I built a few things with wikis as the basic approach, and I think they actually work a lot better as a generic data model than like source of truth a la Wikipedia, for example. So here's some nice things that wikis give you that are quite interesting. So it's a historical database, usually like Git or CouchDB, and you get activity feeds, usually for free. So we have this thing, Oakland Wiki, in Oakland, where I live, and it's fantastic. It's just a wiki about a bunch of random stuff in Oakland, like some important stuff, but a lot of just really silly stuff. And that silliness kind of helps. But what makes it work is the activity feed. The activity feed is just a list of what's happened recently. It's the recent changes section of the website. And I really, really like that data model because if you have a website like that, it's very self-policing. So the users sort of see what happens, and everyone is kind of at the same level of empowerment. So, if someone puts some spam, someone else can just go in and clean it up, and it usually works if you have enough people willing to protect that community resource. So I've got this module called Wiki Db that you can use for wiki-like data. So anything that you want to feed for, or you need to do just basic append-only kind of historical data sets. So let's hop into an example. So there's an API and a command line version. It's all done with LevelDB, which is nice. So you can just npm install -g wikidb. And here's an example of how you might use it. So we'll give it a test directory to start with. Let me just make sure that doesn't exist first. Okay, so you do wikidb and give it a directory, and then I can do create and give it a key name. So the key name would be like the page. So if I create a page called cats and I echo meow, then I get back a hash. So this hash is actually the hash of that content. It's probably 256 or 512. Anyways, just trust me that it's the hash of the content. Oh, I think it includes the metadata. That's why I can't do it on the command line. Anyways, what we have with WikiDB now is I can run the heads command, which is like, heads of cats, and I get back this hash. And if I make a new update, what I can do, maybe I want to uppercase because the cat is getting quite angry now. So, hang on. Whoa, lost my cursor. So I can do create cats, and if I have the heads, I can give it the previous document. So I do --prev equals and this hash. And now if I run, oh, okay. So now I get a new hash. And if I run the heads command again, I get the updated hash. What's cool, though, is that if I'm doing that concurrently across a lot of systems, the data model itself for this wiki database doesn't really care that there might be conflicting versions. It really doesn't have a conception of that idea. So how that might show up is if I create another document again that points back at the first document. So echo conflicts, even though those don't exist in this database. Then if I run the heads command again, I get both documents. And if I want to reconcile those documents, all that I have to do is point back at both of them in time like this. So now if I run heads, there's just a single head, which makes sense. So this is just a simple command line thing that you can use. A cool thing about Wiki Db is that it works in the browser. So I've prepared a little demo here to show that off. Or I could just write this as well. So the first thing you can do to make it work in the browser is you just require level, because you can totally do that in the browser now. Create a new database like whatever.db, and then you do wiki equals require wikidb, and you give it a db handle. And then just to play with this stuff in the browser console, we'll do window.wiki, and we'll also set up a WebSocket, because we can do some replication across a WebSocket. So require WebSocket stream, like that. Great. So all that you have to do is, I've set up a little patch here that maps level to level browserify, and then all that you have to do is run this simple shell script. So I've already done that, and it's running right here, I think. So we've got WikiDB in the browser as well. So we can do things like wiki.create write stream to make some content. So like robots.end beep boop, and that should create a new document. Now, so I also set up a WebSocket. So you can do this really cool thing. I made this little script recently. Oh, hang on. So let me just pop over here, I guess. So I wrote this little script recently called WSNC, which is short for Websocket Netcat. It's just like Netcat. You can listen on a port, just like Netcat, but it's listening on WebSockets. So if I do WSNC and then I connect to localhost 5000, I can say hello. Cool. What's fun is now I can just connect from the browser. So here I'll have the server set up, and I'll just scoot it over here. So now, whoops, well, I guess I'll do it over here. So WSNC-L5000, wsock ws : localhost 5000.end. Wow. So now, oh, whoops. Well, I'll do it on another port because apparently I messed that up. Okay, so 5001, we end the message with wow. Great, we get the message. What's really cool is I've got this command line tool called dupsh, dpsh. All that the dupsh command does is you give it two commands as arguments, and it takes the first command and it pipes the standard out of the first command to the standard in of the second command, and the standard out of the second command back to the standard in of the first command. It's like this. So what that lets you do is, if you have a replication protocol, all that you have to do is have it speak standard in and standard out. You don't have to set up any transports necessarily. So that's how WikiDB works. So if I set up a WikiDB replication scheme, so I'll make a new database, and I'll do the sync command, and then in the other, commands, I'll do WSNC-L 5002. So what this should do is, once I get a WebSocket connection, everything from that WebSocket connection will be hooked up as a duplex stream to the Wiki Db command. This is a really useful technique I found for symmetric protocols. So if I run this command, now in the browser, what I can do is WikiDB has a replication method. So you do wiki.replicate, and that's a push-pull replication. So the first thing I can do is I'll make a WebSocket connection to localhost 5002, and then what I can do is s.pipe wiki.replicate .pipe s. Cool. So if that worked, now I should be able to do wikidb-g temp new data. I think we made a robots document, heads robots. Oh no. I've gotten that heads. Just try keys. Yeah, okay, I guess it was just robot. And we get this hash, and lo and behold, the hash should be what we expect it to be. And it is, hooray. So, just did data replication between Node and the browser with like that 3-line script and a couple of things in the REPL. Fantastic. So, what does this kind of thing mean? I think with that sort of technique of having really easy, pervasive replication, you can start to move your data around without necessarily involving servers, or maybe with servers that other people control, or maybe servers that users themselves run. All of that stuff is really feasible if you have good data replication. So I already looked at that. Also, just for fun, here are some fun other wikis that I've kind of experimented with. I wonder if this audio cable, well, we don't have to necessarily. So the first one is called studio.substack.net. This is the changes log for this website. All that this website is it's an interface, I don't know if you can hear that, for doing live coding for songs. So if you change the numbers, and you can do all kinds of fun things. Anyways, it's fun. Here's some fun things that I've made. This is all just JavaScript on the right. It's just some sine waves and sawtooth waves. But the fun thing about this kind of stuff is that it's in wiki format. So there's no user accounts, everything is anonymous, but people just show up and post all of these wonderful creations to the website. Some people like to flood it, which is funny. I think these are some of the high schoolers that I was showing my tool. Like, I'm hacking your computer, that's fantastic. But what's really fun about it is you see something in the feed, and then you can just copy it really easily, and you can make your own version and remix it. And people have made some really fantastic things. And it's always sort of like, maybe it'll go silent for a few days, and then there's just a flurry of activity. It's really fun. So another wiki that I've been messing with is called Shipboard. So this wiki actually uses WikiDB. So there's an activity feed, and it's kind of like a really early prototype of how a project planning tool might work if it's based on really trivial data replication. So we can make a task, call it whatever, task description, who knows, I'll call it 10 weeks, I don't know. And test dependencies is foo, baz, tags, cool, and then create. So now we get this tag, there's a hash for it. If you click on tags now, I think cool, it builds a Gantt chart for us. So just something to maybe get you thinking that wikis aren't just for strictly text data like an encyclopedia. You can use it for all kinds of things. It's a really really underused data model, I think. But oh, also it syncs. So there's a sync panel right here. So whenever you want to get push your changes or receive new changes, just like get, you just do sync, and then if another browser wants to get data, they can just sync from any server. It's fantastic. Okay, so that's Shipboard. So some problems with wikis, though, are that they can be shut down if the site administrators get tired of them, or they're just filled with spam, and the software is not necessarily going to stay the way that it stays. But this isn't just a problem with wikis. This is a problem with any service that you use. Okay, you're signing in with Facebook today, but how soon before they turn off that API, and then you're super screwed and you have to rewrite everything? These are not really great for us if we want to be editing everything all the time. We have to spend all of this time reconciling third-party changes. But these are really problems that go deeper than that. They go kind of to the core of property and ownership to start with, which usually just ends up with a lot of people owning all of the property. So here's some things that we have in terms of digital property. You might know of DNS or NPM package names, that kind of stuff. These are scarce resources, a little bit by design. I mean, names aren't necessarily terribly scarce, but they are all at the exclusion of other names. So if I want the package name for tap, for example, I know Isaac has that, and so I can't just publish over his content. Although, wouldn't it kind of be nice if anyone could? I think that would be a really interesting research project to have. Anyone can edit any package at any time. A registry like that would be just fantastic. Really interesting for a security researcher, I'm sure, as well. Other things, Bitcoin and whatever, and SSL cartels, these are all forms of property in their own way that we have in the digital era. But I think this quote from Captain Kirk in Star Trek IV, which is the movie where they went back in time to San Francisco in 1986 to save some whales, is relevant. It's a miracle these people ever got out of the 20th century. And so I think instead maybe owning data is maybe not the best idea, but we can certainly own our identities. We have certain autonomy when we make statements, when we author things, at least originally. Owning data is a little bit complicated because then you can just copy it for free as much as you want, so that doesn't really map very well to the technology. But I think this question has been fueling a lot of my research lately. It's how can we build services that nobody owns? Because if nobody owns it, then nobody can shut it down, nobody can take it away. It's just always going to be there, just like open source is sort of, once you release something with a open source license, and then you can just save it, and everyone has it forever, so long as a few people care enough about it to keep it around on some hard disks. So in order to do all of these distributed things, we kind of need some new techniques. So one of the techniques is to kind of dismantle how we think about identity. So identity is actually very simple. All that you need to do is generate an asymmetric key pair, which is fairly simple. You just do SSH key agent, some commands you copy from Stack Overflow on the command line. So let's sign some data with cryptography. That'll be fun. So let's see, I wrote a backup in case I forget all of the steps, but we'll use just a simple elliptic curve module here. And we can make make a new instance of that with this curve, which I've heard from my crypto friends is pretty good. So all that you need to do is generate a key pair and then call sign on that key pair. So if we hang on. So if we take standard in and we pipe that to something like concat stream, then we can sign the incoming blob. So function body, and we'll just sign that body and print it. Okay, so once we have a program like this, now we can have a message, any arbitrary payload, and we'll just pipe it into the signing program. Oh, hang on. Line 8? Right, that extra paren. Great, and we get this hash. It's actually an array, but if you convert it to a buffer, then it looks a little bit nicer. Actually, to hex. There we go. So anyways, you have a message. You can attach a signature to that message. All of a sudden, that signature sort of proves that you wrote the message. So you don't really need to send that to a server necessarily. I mean, you could for safekeeping, but you can also just send that message directly to your peers, like on a floppy disk or whatever. And you could also pass that floppy disk to the NSA first, and the NSA could give it to your friend. And it doesn't matter because your friend can just read the signature, and that sort of proves something about the data integrity. So it's resistant to a lot of different types of attacks. There's also this really useful idea called content addressable data. That's where if you have a key value store, the key that you use is just the hash of the data. So if you have a message, hello, then the key would be that hex value. So one really nice thing about using content addressable data is that the data has to be what the hash is. Like otherwise it's been tampered with or the data has been corrupted in some fashion. So you get kind of integrity checking for free, which is why Git uses it, for example. And also the links can't change, which is really nice. So if you point at something, you know that that's never going to change. So what that lets you do is you can create these data structures called Merkle DAGs, where if in your document you include the hash of another document, you can sort of have a chain of identity that goes all the way back to the root. So if you know what the latest document is, then you can create something like Twitter in a completely decentralized fashion where you're getting nodes from all of your peers, and you don't have to trust them, like, at all. So one nice thing about these data structures is that replication is actually really trivial. So, like, this is how Wiki Db works internally. All that happens is when you create new documents, you append them to an append-only log, and that log just grows and grows, and then there are indexes that are built on top of that. Those are the mutable part. But all of the documents point back like I was doing at the beginning with like -- prev equals. That's the same idea. It's really trivial to do replication and even to do multi-party replication and everything because the basic operation is just concat. So to do this kind of technique, all that you need to do is if you have a message, hello, you put that in SHA-SUM, and then the next message is like maybe you include the previous one in the head. Whoa, crap. So you include the previous message in head, like that. New message, and then that's the hash of the next document, and so on. You just keep doing that, and you have a nice chain of trust, which is fantastic. So there's some modules to help you out with these kinds of, building these kinds of tools. A really fantastic module called Abstract Blobstore by Max Ogden that kind of put all of these ideas together in a really concrete form. So you can use it for things like files on disk or S3 or IndexedDB, whatever you want. But the one that I really like is called Content Addressable Blobstore because it lets you create documents like this. So you just require it, which is the longest thing to type, and you have to spell require correctly. Content addressable blobstore. You create a new store like that, and then you do store dot like create write stream, for example. And once you've done that, in the callback, you get a key property. So that's just going to be the hash of the data that you've sent. So if we run this program, we'll get this hash. So now if we update the program, hang on. If we update this program to read back that data now, find out. We should get back a message, and we do. Great. So, but the nice thing is, all of these techniques also work in the browser. So that's all that I'm doing to make WikiDB, and it's based on another module called ForkDB, work in the browser. All they need to do is swap out content addressable Blobstore for IDB content addressable Blobstore, which is just uses IndexedDB instead of files on disk. So if you browserify blob.js, and if we make an index.html, like that, so now, if we fire up the console, we'll get, store, that's the one. So now we've got the store, we can create a write stream. Key, .end, whatever. And that gives us a hash now that we can create a read stream for. So store.create read stream of, whoa, wrong paste buffer, I guess. Dot on data, and then I'll just whatever, hooray! So that worked. Anyways, that's just a silly, useful thing that maybe you'll find useful. So one really nice thing though is if we want to make systems that no one can own, now that we have this basic Blobstore interface, what if we could do that for BitTorrent? So luckily for us, most other people have done all of the hard work, especially Faras with WebTorrent and Macintosh with modules like TorrentStream. These are fantastic, by the way. Torrent Mount, it can seek into the middle of a file and start streaming it, which is incidentally really useful for things other than movies, like geospatial indexes or all kinds of stuff. Nobody's doing anything with that. I don't understand it. So I recently sent a pull request to this module called Torrent Blobstore to implement write stream support. So just like we've been doing with blob data, all that you need to do to make this kind of thing work for BitTorrent is you just swap out content addressable Blobstore for torrent Blobstore, and when you run that program, you get back a magnet link, and you can just paste that into the create read stream implementation, or a BitTorrent client or whatever, and you get a file with all of your content. Pretty useful technique, I think. So, so what other things can we do to sort of build more peer-to-peer robust technology? So, so WebRTC is really cool, but the peer introduction handshake is actually quite complicated, and you mostly have to go to a server to store the initial metadata payload. So I can show how this works over here. So here I've got an example of just a simple static file. It uses SimplePeer, which is a pretty nice way of doing WebRTC. So the first thing that WebRTC gives you is all of this spam about IP addresses and stuff. So you take that data and you give it to another peer, and this is the signal data. Oh no. All right, that cable is flaky. So then the other peer sends its signal data, which is right here, like so. And I paste that in to the first one, and now if I open up the debugger, you can see it sent some data. So that's not that great. I mean, you can talk to WebSocket, which maybe has a server that sets that up, but the problem is that server is going to live in a specific place. It's probably not going to be very dynamic. If network changes and like servers can go offline, you could do a ring of servers, but then that's a little bit complicated too. So one technique that I've been researching recently is this approach for doing gossip networks, and using a gossip network, Gossip network is basically when you have like a random assortment of peers, and you just tell each other what addresses you know about. And once you've done that, then you can create ad hoc subnets. So what if I could create an ad hoc subnet for WebRTC introductions? That would be a much more fluid, much more participatory architecture. So it's very early stages, but here I've got a server running on the right, and I've got a client running on the left, and they're exchanging addresses. I mean, there's only 2 nodes in the network right now, but ideally, they're speaking WebSockets, so all that a browser needs to do is connect to this network, and then it can use the network to do the signaling introductions. But also, you could use that for so many other things, because if you have a subnetting scheme that works in a peer-to-peer fashion, then what you can do is make little subnets for any kind of peer-to-peer architecture you want. Like if you want to run a DHT, like BitTorrent, you can put that in a subnet. If you want to make a distributed chat protocol, you can just fire up a subnet. And I think this stuff will probably get to the point where all that it takes is like, a 3-line kind of Socket.io style example where you just paste some little snippet into your page, and all of a sudden you've got this amazing distributed, robust architecture to start using. So that's mostly all that I've been working on lately. So hack the planet. Thanks.
All right, we'll take some questions. There has to be something. I didn't see anything on Twitter, so hands, please. No one? Are you kidding me? I mean, is it a joke? Is everyone joking here? Can't see any hands. Really? Okay, there's someone over there. Couldn't see you because the light is like right in my face. It's like being on the beach, basically.
Could you talk a little bit about denial of service attacks and what that means with respect to a lot of peer-to-peer type databases and networks?
Yeah. So the kind of attacks that you can pull off against a peer-to-peer network are a little bit different. So denial of service attacks mostly take the form of like Sybil attacks, where you spin up a bunch of nodes that just spam the network with just garbage information. So one of the techniques that I've seen for addressing that is to, when you get addresses from your peers in a gossip network, what you can do is you keep track of where that information came from, and then you throttle based on all of the nodes. So you do like round robin kind of style balancing of the address scheme. I haven't actually tried that yet, though, but I've read a little bit about that technique, so that's something that I want to try, but I'll have to see if it actually works.
Anyone else? Upstairs, still asleep for second in a row. No one else? Okay. Going once? Going twice? Seriously?
They can just ask their questions out in the hall.
Yeah, that's true. That's true. Okay. Oh, no, there is a question.
Have you ever thought about like making Git, which is a distributed protocol, like actually distributed, like to propagate to multiple nodes automatically, maybe even with issues or pull requests?
I've thought a little bit about that. I think some other folks are researching that a little more heavily, but I mean, so one problem with automatic propagation is that you have to sort of have a pre-existing arrangement with other peers, so that, because otherwise, like, why should some random server accept random data from people that it doesn't know about, right? But I think it's possible to kind of establish trust relationships with nodes, but it's a little bit tricky. In terms of stuff like the metadata for like pull requests, that's probably not that much data, so that might be a little bit lighter weight. So one thing you could do is basically build Twitter over a peer-to-peer network, because then you can just use that for a feed of data. And if you have a feed of data, you've got an append-only log, and you can create indexes and whatever other kinds of information you need on top of that log. So once you have that basic infrastructure in place, oh, I didn't mention it in my talk, but I've also got a pull request. There's an extension to the BitTorrent protocol called extension 44 that lets you treat the DHT as just like an arbitrary key value store, pretty much. So you could store like a pointer to a feed, for example, and that feed could be content addressed, and it could just point backward. You could do that kind of a trick for GitHub, but I think a lot of the value in something like GitHub hosting is just all of the UI stuff, and like we can get the protocols down pretty well, but we also need people to come in and like make a usable UI. That's often the thing most lacking in open source projects, I think.
All right, let's take it.
I have a question. It's nice to do SAM checks like this in small sample, but what if you have like really huge systems and you do SAM checks of all content like every time, and it's like, you know, millions of tweets, as you say, Twitter. But what if you had really Twitter data and it would be peer-to-peer and it would be so long? Would it be just slower and slower?
Well, so I've not done very many simulations with too many nodes yet. Mostly just researching things. So one of the techniques that you can use to achieve scale, I mean, if you think about a network like BitTorrent, I mean, it has really interesting scaling properties, because the more people use it, the better it works for everyone, because nodes are helping to distribute the address information, they're helping to distribute files. But I think ideally, these kinds of networks, especially PeerNet, tend to work better the more nodes you have. And actually, they kind of don't work very well if you only have like a few hundred nodes, for example. So.
Okay, we have to be done right now. So if someone has any further questions, they will have to find you in the hall. Okay, thank you.
Okay.